Let's start by calling for the presentation from Saskatchewan Research Council as outlined in Commission Member Document 16H16.1 and 16H16.1A. And I understand that you, Mr. Muldoon, will make the presentation. The floor is yours.
Good afternoon. For the record, my name is Joe Muldoon from Saskatchewan Research Council. I am the Vice President of the Environment Division at SRC. I have with me today the Manager of the Environmental Remediation Program, Ian Wilson, the Chief Scientist for the project, Alexei Kalashrin, behind me to my left, Sky Kettleson, the Other Sites Aspect Project Manager, behind me to my right, Mark Collette, Senior Advisor for the Community and Aboriginal Engagement, behind me. Mark Listowich, Principal Consultant, to my right, far right. And Trevor Podema, Senior Consultant, both of which Mark and Trevor for our design consultants, SRK. To my left, I have Corey Hughes, Executive Director of Mineral Policy for the Saskatchewan Ministry of the Economy. So I'll just start the presentation. As you know, SRC is here today applying for a license hold point release for the Gunnar other site aspects remediation activities. The release of this hold point will allow SRC to begin final planning and procurement processes for this work, and most importantly, allow this component of the remediation activities to be integrated with the tailings cover construction already started. This will result in a much more holistic approach to site remediation and allow a more effective and efficient project implementation. Next slide. The purpose of the Gunnar project is to reduce the safety and environmental risks that the site poses to the public, utilizing sustainable remediation options that are both technically and economically feasible. It's also to implement a long-term environmental monitoring program and minimize long-term care and maintenance at the site as part of the eventual entry of the site into the Provincial Institutional Controls Program. Both the requirement and benefit of the Gunnar project has been the development of a meaningful engagement strategy with local community members over the course of the project. As stated in the Gunnar Environmental Impact Statement, SRC understands that it has a duty to consult with local Aboriginal community members about possible effects of the remediation project. Based on feedback from industry, Aboriginal communities, and government, we feel that SRC has a leading engagement strategy in place for its legacy mine remediation projects. We will present a short video at the end of this presentation which covers the last community visit to the Gunnar site in August of this year. This slide provides a brief update of what has happened with the Gunnar Tailings project since the hold point was removed last year. So the tailings remediation hold point was removed in December 2015. We've completed the detailed remediation design report. We've awarded through procurement the remediation contract to a Fond du Lac Nuna joint venture, Fond du Lac First Nations being found within the Athabasca Basin. And we've started site preparation initiation in September of this year. We're underway with that as we speak. And we will begin the full remediation operations. We'll really get into the bulk of the work in the spring of 2017. I will now turn the detailed description of the project over to Ian Wilson, the Manager of the Environmental Remediation Program at Saskatchewan Research Council.
For the record, my name is Ian Wilson. To facilitate SRC's project management and corresponding with the CNSC license structure, the Gunnar site has been divided into the tailings and the other aspects. For clarity, the remainder of this presentation will focus on the other aspects with the goal of removing the license hold point. The other site aspects are defined as non-contaminated demolition debris, which consist of asbestos-containing materials, steel, wood, and concrete, contaminated and hazardous materials, which consist of hydrocarbon-contaminated soil and rock, treated wood and pH-impacted material, waste rock, the general site, which consists of 3 mine openings, catchment 3 drainage, incidental site debris, and areas of gamma over the objective levels, and the water-filled open pit. The specific objectives of the Gunnar Other Site Aspects projects are the stabilization of waste rock piles to minimize human health risks posed by the gamma radiation and the slope instabilities, minimize of contaminant releases from the tailings and waste rock to Lake Athabasca, permanent disposal of all waste materials in a manner that is environmentally sound and meets regulatory requirements, remediation and recontouring of the landscape in a manner that is compliant with the natural surrounding and future use of the site, and taking measures to ensure conventional health and safety. The major sources of risk to public safety and the environment that the other site aspects currently contain are physical hazards, for example, waste rock slopes, metal debris, and access to the underground, exposure to radiation found on waste rock and mill debris, exposure to chemical contamination found in waste rock, remaining mill process chemicals in the acid plant area, and potential exposure to asbestos-containing materials. The remediation objectives for the Other Site Aspects project, as taken from the EIS, is the long-term mitigation of residual public safety and environmental health risks applied to radiation exposure, water, and air quality. To specifically meet these objectives, a remediation plan has been developed to, 1, consolidate and permanently dispose of the non-hazardous demolition debris, 2, consolidate and permanently dispose of contaminated rock and debris, 3, stabilize waste rock slopes, 4, reduce gamma exposure through use of an engineered cover, 5, minimize contaminant loading to St. Mary's Channel and Zemo Bay, and 6, monitor the site to ensure public and environmental safety during and after the remediation work. Remedial options were generated through the decision tree process of the EIS, through consultation with community members during meetings and workshops, and by review and input from regulatory authorities. Remedial options were evaluated using a number of facets, including safety, which is the #1 priority on this project, the decision tree from the EIS, which you have seen before during previous commission hearings, multiple accounts analysis, which is a quantitative process that assigns numeric values to options based on risk, adaptive management, cost, and public perception, and input from local community members. From the evaluation of all options, preferred options have been identified for each site aspect and will be presented in subsequent slides. For the non-contaminated demolition debris, which is marked in blue and consists of asbestos, steel, concrete, and wood, the preferred option is to construct an on-site landfill in the mill and acid plant area as marked in yellow. The landfill will be constructed in accordance with Saskatchewan Ministry of Environment regulations, classified as Type 1 waste, and house approximately 99,000 cubic meters of asbestos, steel, concrete, wood waste. The advantages of this remedial option are a low risk of differential sediment, low permeable nature of the bedrock floor, good public perception ranking, situated away from Zemo and St. Mary's Channel, the shortest haul distance, which equates to the lowest cost, and allows for flexibility in unforeseen events and adaptive management. The execution of this landfill will be to haul and place demolition debris on a prepared landfill base, cover with approximately 19,000 cubic meters of concrete, and followed by a 0.5 meter thick cover of clean, locally sourced aggregate. For the contaminated and hazardous materials, which are marked in red, the preferred plan is to excavate the acid plant material, which is pH impacted, and hauled to the tailings area, while the remaining material, consisting of approximately 4,000 cubic meters of hydrocarbon impacted soil and rock and contaminated wood, will be consolidated into one landfill marked in yellow. The landfill will be constructed in accordance with Saskatchewan Ministry of Environment regulations, classified as Type 2 waste, and be a dry tomb concept built on competent bedrock floor. The advantages of this remedial option are utilizing existing bedrock foundation, good public perception, it's situated away from Zemo Bay and St. Mary's Channel. It is the shortest haul distance and allows for the maximum flexibility for unseen events. The execution plan for this landfill will be to excavate pH-impacted material and bury under the tailings cover, prepare the bedrock foundation for landfill base, and cover with 1.2 meter thick, clean local aggregate. The remedial objective for the waste rock, as taken from the EIS, is to remove physical hazards to humans and wildlife, reduce gamma exposure, reduce human health risks, and reduce ecological risks from uranium loading. For the waste rock pile marked in green and gray, the preferred remedial option is to reestablish the historic channel and grade, cover, and revegetate the waste rock piles. The advantage of this option is it presents the least amount of risk compared to other options, allows for adaptive management, is highly favorable compared to pit fill option due to significant disadvantages of backfilling the pit discussed in later slides, more economic than other options. This option calls for the removal of approximately 851,000 cubic meters of waste rock overlying a historic stream bed for integration into the tailings as grading material. The remaining waste rock pile will be resloped, drainage features installed, and covered with 0.5 meters of local aggregate and revegetated. The waste rock underlying the former tank farm and camp will also be regraded. This slide shows the proposed post-remediation landfill and waste rock landforms. The landfill and waste rock slopes will be graded between 4:1 and 5:1. Microtopography will be incorporated into the slopes to break and promote vegetation and reduce erosion. For the remaining general site items, which consists of openings to the underground, elevated gamma areas, and additional incidental debris, the preferred remedial option is to cover the access to the underground with stainless steel caps, cover the elevated gamma areas with 0.5 meter of local aggregate and revegetate, and remove incidental debris and place into the appropriate on-site landfill. The advantages of this option is that the steel caps provide a strong, durable, and easily fabricated and modified mechanism to prevent access to the underground, while the local aggregate cover provides radiation insulation while eventually blending into the surrounding landforms. The remedial objectives for the open pit, as taken from the EIS, is to reduce human health risks, reduce ecological risks, and provide structural stability, which it is now doing in its current form with the water. This animation shows the pit from an aerial photo vantage with both the pit depth and the underground workings to scale. This animation shows a 3D rendering of the open pit and underlying mine workings. The animation will stop momentarily to align from the perspective of the previous slide. It should be noted that the pit is just a surface expression of a much larger underground system that goes down 600 meters from surface. Also of note is the red oval in the pit, which is an approximation of the opening of the pit to the underground scaled based on historic information. These animations were used successfully to convey information to community leaders, who are very grateful for this form of visualization of historic information. For the open pit, the preferred remediation option is to reduce loading to the pit by dealing with other site aspects and through the development of a monitoring plan to access the outcome of reduced loadings. The overriding advantage to this option is safety. Other options, including dewatering and infilling with waste rock, have an inherent risk to worker safety during implementation due to uncontrollable pit wall stability and subsidence of material from the pit to the underground. Other major advantages of this remedial option include no adverse effects on aquatic or terrestrial plant and animal populations. It allows for adaptive management in the future and a reduction in loading to the pit from its current state in red to the proposed state in black. This table generalizes and shows all site aspects in its current condition when applied against the criteria from the EIS and the proposed preferred remedial options. As you can see, all the EIS criteria have been covered by the proposed remedial options presented today. During future implementation of the other sites aspect project, SRC will rely on its robust and field-tested project management approach, which consists of its corporate ISO 9000-2009 system, site-specific management system, which consists of programs and plans related to safety, radiation protection, environmental monitoring and protection, communications, training, and quality, and the execution plan, which includes project charter, governance, milestones, risk registry and management, management controls, performance management, quality management, financial controls, communications, consultation and engagement, environmental protection, safety, procurement, regulatory, and resourcing tools. SRC also manages and maintains an 80-person camp on site and the associated infrastructure that will be utilized for this project during implementation. SRC's anticipated forecasted timeline and milestones for the other site aspects and tailings projects consist of remediation work between 2016 and 2022, post-remediation monitoring between 2022 and 2035, and entry into ICP after 2035. Since the start of Project Cleans, SRC has conducted more than 135 formal meetings with community members. SRC continually communicates with community members and leadership through radio, print, our website, faxes, posters, fact sheets, teleconference, direct mail, email, text, Skype, Denny interpretation, and Facebook. To provide a better framework for its interaction with the community representatives and leadership, SRC has conducted multiple site tours. As part of the previous Gunnar demolition and materials abatement activities, SRC and its contractors have conducted asbestos abatement training, safety training, and radiation training. As part of SRC's management of Project Cleans, it has expanded this training to include essential skills training, driver license training, heavy equipment training, and will continue to expand its training programs following input directly from community members. Other ways in which SRC engages with community members in the Athabasca Basin region includes through the Athabasca Sector Gathering, capacity and training initiatives partnered with the Prince Albert Grand Council, local site monitors providing independent site auditing, inclusion of community members on public procurement teams, SRC participant funding for its engagement events, which includes travel, accommodation, and honorariums, local Aboriginal labor inclusion, which is greater than 50% in all of our projects, and presentations made during environmental quality committee meetings. From feedback received from private industry, First Nations, government, SRC has been told that it has an industry-leading community engagement strategy. As part of this strategy, SRC has pushed the boundaries of public procurement to maximize local involvement and sustainable development opportunities. As such, SRC has been nominated for both the Government of Saskatchewan Premier's Award of Excellence and the Canadian Public Procurement Council Achievement of Excellence in Procurement. SRC has developed and will continue to support strong mutual relationship with the leadership and people of the Athabasca Basin region. Specific community engagement events that have taken place to facilitate the creation of other site aspects remediation reporting includes hosting a workshop and submission of preliminary remediation design report for CNSC and public review in August of 2015, travel to Black Lake, Stony Rapids, Hatchet Lake and Wollaston, and Uranium City from December 1st to 4th, 2015 for community meetings, hosting a Gunnar Other Site Aspects workshop in Saskatoon on April 26, 2016, hosting an on-site leadership tour of Gunnar Mine in August 22nd, 2016, and hosting the Gunnar Other Site Aspects workshop in Saskatoon on August 23rd, 2016. SRC continues to work with community elders from the region to integrate local plant knowledge into its revegetation strategy for Project Clean sites. This knowledge exchange is conducted in both the communities and at the sites themselves. In partnership with the Prince Albert Grand Council, SRC created and facilitated the Student Environmental Monitoring Project at the Gunnar site this summer. This program will be an ongoing mechanism for developing an awareness and spark for environmental sciences and engineering for local young people in the Athabasca Basin. It is hoped that working with our project partner, SRC can develop local expertise in the region to monitor the Gunnar and other remediated sites into the future. I will now pass the presentation over to Joe Muldoon.
For the record, Joe Muldoon. Just before we close our presentation, I want to share a short video outlining community member comments from our last site visit in August of this year. When we hear community members describe the project and tell our story, we feel that our Aboriginal community engagement activities have been successful. It is our intent, as mentioned already, to continue this dialogue with communities throughout the project. With your patience, I will also show a very short video. These are always very short. Videos are good. I want to show a very short video that describes SRC's approach to meeting the challenge of managing the multiple data that's created with these kinds of projects and ensuring that this data is stored where it can be used now and be accessible into the future. You know, as evidenced by some of the animations that we showed earlier. They were instrumental in terms of explaining to communities the impacts of working within the pit and why we wanted to go with the options that we have before the Commission today. So this information is just the way that we've been able to develop some of this geospatial applications has been very helpful. So I'm just going to move quickly to these two slides to show the community leaders first, the tour.
It was an abandoned mine that was just left. There's no law in place to do any cleanup or anything like that, so nobody really pushed for a cleanup until now.
One of the main concerns of our people is the impacts of the contaminants that's in the water, that's in the land.
I'm not pleased about it, but what can one do? The damage has been done already, and so with that, we can only assess the damage and hopefully one day it'll be all cleaned up.
What you're walking on now this is the tailings.
With the tailings, I know I don't know how many football fields, it's massive.
That's where they used to pump all the waste from the mine.
As you can see, they're pretty fine, and if you get a good wind, they can blow. After all the study that we've done over the years and talking with people in the area, we're going to cap these tailings using some of the material that's naturally available, the clean material. So anytime where the snow melts or anytime where there's a rainfall event, instead of going into the tailings themselves, picking up contaminants within the tailings and running back to the water, it's gonna shed, just like a roof on your house is gonna shed it.
There's 3 sections of the tailings and they're gonna start tackling one at a time, I guess, and hopefully clean it up.
If it all works out, it'll be great. It's, you know, shutting off the source of the contaminants flowing into the lake.
We're putting and designing an engineered landfill to place all the material that you see around.
You see all the waste out there, all the metal and stuff like that. It's not going to be taken out of here, but to put it in a place that you can contain it, that it's not scattered everywhere, which is good.
It's a positive step in terms of remediating, cleaning up the site.
It's getting better every year, so hopefully with this project that's going to happen here, it'll make it even safer, which will be really good.
And our people are going to be here long after any mine site that's in the region. We're not farmers. We go out, our grocery store is out in the bush and out on the lake. So we want to make sure our land and our water is safe for future generations.
This brief presentation outlines SRC's environmental data management system for site remediation. Data that's collected during site remediation work is usually spread across multiple documents and can be difficult to access. To help streamline this process, SRC developed a holistic environmental data management system, which enables data to smoothly flow from its initial collection through the centralized data storage to project stakeholders. In the system, all data can be accessed through a web portal, which doesn't require any specific technical skills. This map shows the former Gunnar mine site and can display locations where environmental samples were taken. The map features a dynamic legend and pop-up menus with additional information about each sample and its location. Users can view historical mining structures and wastes, and access historical and recent photos from certain vantage points to see how the site looked before remediation began and how it looks now. Gamma dose rate patterns can also be accessed, and specific values can be viewed across the map. The web portal also allows users to overlay aerial photos from different points in time. Users can swipe between images to compare them, and the same can be done with historical drawings of the site. The system also incorporates underground data. This view shows the Gunnar mine's underground workings in scale with an aerial photo. SRC's system also includes a 3D model of the underground features and corresponding statistics. When it comes to reporting, data can be easily gathered in a preset reporting-ready format within minutes. Sample analytical data can also be easily gathered for a specific location, media, or parameter. SRC's environmental data management system enables swift data processing and analysis, and creates new opportunities to use data for well-informed decision-making.
And that concludes our presentation from Saskatchewan Research Council.
Thank you. Thank you very much.